Okay, we're reviewing for that loans and investments test. First of all, calculator is a big part of it. And I taught you a new app. Let's look at the new app. Everybody go in there. If you're going to have a loan of 5,000 bucks, actually this is 50,000, sorry, a loan of $50,000, do you remember that the present value then is negative $50,000? If you don't have a negative in there, it sort of works. It's like, it's kind of evil. It works. It'll give you an answer that's close, but it's not right. So it'll be off by, enough to make it wrong on the test. So be careful. If it's a loan, that's a negative present value. Okay, next, let's do the same scenario I have right here. N is 120. That's 120 what's? Nerf balls? N stands for, and it could be months. It could be, it's payments. Now, we pretty much usually make it months. The way you can tell it's months is down here under P/Y, payments per year. And usually that's months, although every now and then we'll throw in quarterly, which would of course be 4 payments a year. All right, but for right now, let's make it monthly, and this payment amount is the thing you usually solve for. So everybody see if you can get that 580 to show up there. Right now, if you don't have that there, which you probably don't, probably have like a 0 there or whatever, you can solve for it. And that's the special thing about this calculator is if you put in all the info, it can solve for any one of these variables. So I'm going to do, it's an alpha enter, which does a solve 580.54. Now what did we just figure out? The payment you need to make in order to pay it off in 120 months, or that's the same as 10 years. All right. So now let me change it to this. This is I'm going to do a typical car loan situation. Yes? Okay. Then I'm guessing you had 5,000 instead of 50,000. Is that possible? All right, good. All right, so let's change this to a typical car loan situation. People usually don't borrow quite this much to get a car, but people usually pay it off way faster. Okay, a typical car loan is a 5-year loan. So everybody change this to 5-year loan. And a typical car loan, to get a smaller car, you might only borrow, let's say, 30,000. So make it a $30,000 loan, but for 5 years. 7% is a typical interest rate. Again, you can do better than that if you've got really good credit and stuff, but so please change this to a loan for 5 years of $30,000. How much would your car payment be? And I think you can see with just changing a couple numbers and hitting alpha solve, it's really easy. All right, so up here, remember that you don't have to even calculate that in your head. You can say, all right, 5 years, 5 times 12. That's how many payments I would have. 7% we left. This is 30,000. I'm leaving the negative in there. Changing that to 30,000. Moving down to here, new payment. Did you get 594 bucks? All right, so there you go, typical car payment. And you can see how easy it would be if mom and dad were like, I wonder how much the car payment would be if I had this. You can tell her. It would be really easy. Now, granted, it might be off if the company is doing payments at the beginning of the month instead of the end of the month. You know where to change that, right? We're going to keep sticking to doing ours at the end of the month payments. But if, they wanted to do something weird like they don't compound it 12 times a year, maybe the bank is going to compound it like 365 days a year. And then, that would change things a lot, obviously. So anyway, bottom line, you're able to use this thing in the real world for loans. How about investments? Let's just take 2 seconds to say, let's say you wanted to save $200 a month for the rest of your life. And let's say you get 7%, we'll just say that's the same, 7% in the stock market. And how long is the rest of your life? Let's say it's your working life. Let's say from now until the end of you being done working. If you were, let's say, 15 years old right now and you want to work to age 65, that's probably 50 years, right? So you've got 50 years of working that you could do this. You now know enough to figure out your future value. Would you please compare it? $200 a month, $200 a month, 7% interest, or growth in the stock market or whatever. You're going to be comparing it with the person next to you in a moment. Any other things you need to know? I can repeat anything you needed. Doing this for 50 years. Okay. We have a lack of people in this row over here, so we're going to have you two compare with the guy in front and behind. You two are going to go diagonal right here. You two are straight across from each other. You three, 1, 2, 3, are going to compare. This row, you're going to go diagonal up, diagonal up, diagonal up, and then you two are comparing with each other. Okay, you two are straight across, and you three in the back corner. See if you got the same things. So, 60 payments? Nope, a lot more than that. If you're going to go for the next 50 years, you go 50 times 12. Nope, I did something wrong there. I'm going to go up here and say 50 times 12. There we go, 600 months. All right, interest, 7%. And present value, did you guys put 0? Good. And payment amount, we're going to put in 200 a month. And future value is what I want to know. And you got just over $1 million there. And so is it possible to become a millionaire? Absolutely, yes. Yes, because I didn't put in a negative payment. If I put in a negative payment, I think that would fix it. But don't stress about that. I think you all know you're not going to have a negative $1 million, right? All right. The big one that I got to make sure you know is that if you take a loan out, you've got to put a negative on the present value. If that's not negative on a loan, it will be dangerously close to right, but not right. Okay, so that's $1 million if you get 7%. I just want to see you get the difference, why you might want to strive to get a better return than that. Let's change that to a 9%, everybody. Remember, it was just over $1 million at 7%. Change it to 9%. And now figure out your future value. Do you get why some people make it their hobby to try to really do a good job on their investments? You get 7% compared to 9%, you get an extra $1 million. Holy crap. So now just knowing a lot about your investments doesn't really, do much for you. You got to actually put it into practice, and you got to actually have that better return. But if you can get 9% instead of 7%. Now this is one of the things that tempts people to do like what Bernie Madoff was doing. He was completely ripping people off. He was saying he was getting above average stock market returns more than anybody else. And he was, telling his clients, showing them proof. It was totally fictional proof, but he was showing them proof how he had gotten a couple percent more than all the other guys out there. And he was like, everybody, a lot of really rich people, a lot of famous like movie stars and stuff were using him because like, hey, extra 2%. Why were they willing to take a risk for an extra 2%? Because of that. Because they knew that, look, I can get an extra $1 million. So you got to be careful too that you don't end up chasing that extra 2% and then losing all your money because you put it in a scam. So, all right. So enough of that. Let's move to a typical test type question. I'm going to help you with this one. I'm going to run through it real quick, and then I'm going to ask you to do the next one. Okay, this one's mine, but watch and learn for a moment so you can apply it right away on the next question. Same kind of question. This one I can tell right away from the minus sign, it's a loan. The annual interest rate, don't get sucked in. That whole thing is not the annual interest rate. Just that. And if I write 0.055, I get it wrong. 5.5%. You get that? Okay, the next thing. Payment or deposit amount. The payment is this 25. The principal, that's the original starting money, 350. How much is still owed at U sub 6? All right, all I have to do is look on my table and find U sub 6, and I could find that amount really pretty easy. What does U sub 6 mean in terms of time? I have to remember that this is monthly, and therefore it does not mean 6 years, it means 6 months. And when would this be paid off? You look on the table for the dollar amount to be dropping. Let's say it drops to 200, and then it drops to 180, and then down to eventually 100, and eventually this thing drops down to negative $14.35. At that moment it turned negative. That's when it's paid off. And don't say between here and here. Don't do that. It's paid off right here when it hits its first negative number. And then they owe you money back. That negative means they owe you money back. So let's say this had been 25 payments. You'd go 25 payments times my payments were 25 bucks, but I subtract off the money they owe me back. So 25 times 25 minus $14.35 they're going to send me back in the mail. Okay, that's how you figure out its total, like when this thing would be paid off. Actually, this was beyond what I had to do. I just had to identify this month as the month it was paid off. What's its long run value, and can you do it algebraically? I know you can all type this in the calculator and then arrow down the table a whole bunch of times, and you'll eventually find the long run. But can you do it algebraically? Do you remember that? Do you remember that in the long run, two terms that are right next to each other are essentially the same thing? Like a million, if I'm counting the even numbers and I get to 1 billion, that's an even number. And the next even number is 1,000,002,000. And that's incredibly close to each other percentage-wise. In fact, they're so close it's negligible. You would never say, I'm $1,002,000,000 heir. I'm a billionaire is what you'd say. You wouldn't care about the $2, right? So the point is that this and this are essentially the same thing. And therefore you put an X in for both of them. Now with a calculator, it'll help you to do this number crunching, but you have to show it algebraically. So you'd have X equals X times all of that. Would I use a calculator to get it? Yes. Notice I'm not going to subtract 25 from it though. I'm just going to figure out this right here and say X equals whatever that is, some decimal, times X. Somebody with the fast fingers and a calculator, try it once. What's 1 minus 0.055 divided by 12? 0.7, what? 0.7875 x minus 25. Okay, so all I did was figure out the thing I circled there and put that in front of the x. And then I would solve this by subtracting that 0.08075 from both sides. So I have minus 0.07875x minus 0.07875x. And these cancel. And then when I have my decimal, I divide both sides, and I'll get my final answer. My final answer is a negative number, I think. I think it is. I think it's a negative number. All right. So now that's a run through on how to do those. Now I'd like you to actually try this one. It's the same basic thing. And this is an investment, and I want to right away call out the fact there's something weird about it. It's an investment, I can tell from the plus, but what's weird about it? Yes? It's decreasing. That is weird. Investments don't normally decrease, but sometimes you invest in something that turns out to be a bad idea. I did that once. It was a company called ADC Telecom. ADCT was the stock ticker. And it went from when I bought it at first, it was about $15 a share, and went down, 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 down. I wrote it all the way down to $1 a share. So in other words, everything I spent $15 on was now only worth $1. And I did that with thousands and thousands of dollars. So, you know, some people will only tell you their successes. I will tell you that I've screwed up in the stock market. You just never know. You can't be sure. So sometimes it goes down like this one. This one's going down. I'm going to pause for a minute while you try to answer all 8 questions. The first few would only get you a C. If you really want to get an A on this test, you'd have to be able to answer all the last ones. I did screw up in double number 6, but they're separate questions. Okay, for those following along at home, here's what we did. Checking it. Loan or investment. That one right there, investment. Annual rate, 7.5%. Important not to say 0.075. And definitely don't include the 12. Payment or deposit amount, 25 bucks. Principal, the starting amount, 1,000. All those are easy. How much is still owed or owned or owed? And in this case, it's owned because it's an investment at U sub 6. Now, it might be depressing because it's probably going down. I'm going to pause for a second. Okay, so I'm putting this into the calculator here. It's dropping 7.5%, and it's compounding monthly. And then I'm going to add 25 bucks each month. All right, and then my min is the UN min means U sub 0, and U sub 0 was 1,000 bucks. Right? I want to double check that. Yes, it is. Okay, good. So then, what do I have left at U sub 6? U sub 6 was out here on the table. Oh, I'm realizing right away that it probably is in a weird place on the table, so I'm going to hit break. And I'm going to go to table settings, and yep, it was. I'm going to go to table start at 1, and then go to my table, and 6 is $1,110.80, and if you did that, you just got it wrong to the penny. It's $1,110.76. Did anybody make that mistake? All right, hopefully you caught that because it's really easy. If it's to the penny, you got to be careful over there. All right, next. The how much is still owed? Well, owned, sorry. In this case, it's owned. Our money has gone down. No, wait, it's actually gone up because thankfully, even though we were losing some money every month, we were gaining enough by putting in 25 bucks a month that it was still going up a little bit. All right. And so then, what does U sub 6 mean in terms of times? Hopefully you said 6 months, not 6 years. When did this be paid off? That's kind of an irrelevant question on an investment. I guess you could say never, but it wasn't a loan. Number 7, what's its long run value? Well, if you just keep arrowing down, you'll see its long run value, and it looks like it's starting to zero in that $1,200 range, maybe 13. Did you get there did anybody do it by arrowing down like that? Okay, you just did it algebraically. All right, so then I'm hoping, looks like it's still going up here. Looks like 14, maybe 1,500. Okay, so I guess I have to do it algebraically to figure it out. So I'm going to change this to an X and this to an X. And then that's a decimal I can get on my calculator. And so I'm going to say X equals, and then please help me, what's that? So I don't have to type it in my calculator. Point what? 99375X. And then there's this plus 25 at the end. Okay, and then I solve by subtracting 0.99375X from both sides. And then I end up with 0.00, what was it? Something, 00 what X? 625X equals 25. And then I divide both sides by the 0.00625. 625. And what is 25 divided by 0.00625? What? 4,000. Oh, it grows all the way to 4,000. All right. Cool. Any questions on that? That was definitely the hardest part. Okay. And that was proving it algebraically, and I did it by setting both UN and UN minus 1 to X. And then I got to find out this decimal to put here, and then I subtracted that from both sides, and then divided by this little tiny number on both sides, and I had my answer. All right. This is a good R3 style question. See if you could get one of the questions right that you need to get an A or a B. The ones we did before, except for the very end of that last one. That was a tough end of the last one, but all the other ones were like easy R2 kind of stuff. This is like an R3. Put this into your calculator and see if you would be able to find me the value at 10 years and write me the recursive. I hope you're starting with use of 0. Yes. Individual thing? All right, I'll come over there just a second. Okay, I'm changing my equation now to match this problem. And it's plus, because it said it's positive, like growth of 8%. And instead of 075, I'm going to put 080. And it's monthly, because I've got deposits of $1,500 a month. So I go to my plus, and I'm like $1,500 a month. And then it started with a lot. It started at $350,000. And then I go to 10 years. So I'm going to go out to my table settings, and I'm going to just start right away at 10 years, which is 10 times 12 is 120th month. Okay. Calculator's running forever. All right. 120th month. It looks like just over $1 million. Everybody get that same thing? Raise your hand if you got that same thing. Okay, good. If I didn't, then something was probably slightly wrong in your equation. Any questions on that one? Okay. Then the actual, how does it look? How many of you remembered the n is greater than or equal to 1 thing in your equation? Otherwise, you lose 5%. U0 equals 350. UN minus 1. 1 plus 0.08 divided by 12 plus 1,500. All right, there we go. Here's your equation. And the value was 1,051,000 or so. Yes?
How come if you require us to put the name, none of
the calculator doesn't?
Or no, the help that we're actually doing have
Good point. You don't need the domain to put it in the calculator. But, and you're right, that I've seen it on the keys before, and I've seen it in these questions, obviously. They don't have the domain. It's sort of like the fine print on a car ad. You know what I mean? You can tell how much the car is going to cost without the legalese junk at the bottom. It's kind of like covering your butt. Well, we expect you to know that part, that's all. All right. You're borrowing $800. You're going to pay 7% interest, and you're making monthly payments of $50. It's kind of a small-time loan. They do these. That's about the smallest a bank would want to do is something like $800. They don't want to set up a loan for just a tiny amount of money. Would you please set this up in your calculator and answer these questions, especially this part? This is the kind of thing that separates the A's from the B's. Can you answer all those things really carefully? We've been going almost a half hour here, and you're doing well. We're almost done. Got one more concept we got to cover after this. Ooh, the rare round number. Did you get 524 for 6 months at the 6-month mark? Okay. And when is it paid off? Well, I'm just going to use the arrow down method. I'll be able to see when it's paid off. Looks like 17th month. Do you guys have it 17 months? Okay. Now, here's where you really can tell if you got this at the A level. How much did you pay? All right, well, you made 17 payments of 50 bucks. 17 times 50. But then you have to subtract off how much they owe you back. And if you're really good, you're going to make sure you get that to the penny. And you're going to go over here. $7.70 is what they owe you back, minus 7.70. And if I go 17 times 50, I'll go quit. 17 times 50 minus the 770. I know my calculator will do my multiply before I add. And there we go, 842.30. But wait a minute, I thought I only borrowed 800 bucks. Why is it 842 that I paid? Because of the interest. So since it was 842.30, the $42.30 was the interest. How many of you feel confident on that part? You're going to nail that part. Okay, good. If you don't, then you should come in the morning, because tomorrow's a Tuesday and I'm here. If you wanted to, you could do that problem for extra practice. Don't think we need to. Long run value. You know how to do it by the calculator. You just put this in the calculator, arrow all the way down the table. Easy. Okay? You know how to do it algebraically. But do you know how to set the long run value other than guess and check? If you want the long run value to come out to a certain amount, let me just show you the difference. This one I would start with 2,000. Do you remember that we never care how much we start with? In our solving, we never even use that number. UN, that's definitely counterintuitive, by the way, because usually how much you start with makes a big difference in the real world. But in the long run, how much you start with really doesn't matter. It's what you're doing every month and how much it's growing that really makes all the difference. Okay, UN and UN minus 1. And then I have 1, and these don't even work unless you are having decay. 1 minus 0.05. And then this is monthly. As soon as it says it's monthly payments, I know it has to be divided by 12. And then I'm adding 500 a month. Okay, now to get the long run value, you'd know how we do this, right? We'd put an X here, we'd put an X here, and we would, you know, figure out that decimal. I don't know what it is, but it would be some really, 0.99 whatever. Okay, what's the one thing we could change if we wanted a different long run value? Well, if it's given to you that we have to use 5%, and this doesn't even matter, the starting value, we don't even use it. If we have to get 5%, the only thing we can change is how much a month we put in, right? So let's say that it's not coming out to be enough. We want to have more for our long run value. Well, of course, you have to put in more right here. And you could guess and check your way all the way to finding out the answer. But, like you just keep playing with it, stick in another number, stick in another number. All right, but here's what you could do. You could say, I don't know what this is. I'm going to call it N. Okay. And we'd set this thing up and say, okay, let's actually do this part. Somebody with fast fingers, what is 1 minus 0.05 divided by 12? 9958. Thank you. Close enough. And then plus N. I don't know how much yet. Now I'm going to subtract 0.9958x from both sides. And this cancels this. And now I have a really small decimal, 0.00 what? 416x equals 10. You with me so far? And now I'm just using an n because I don't know what to put there. I don't know how much it should be. Divided by 0.00416, divided by 0.00416, and guess what just happened? I solved for x. But what if I knew what x was? What if I knew that I wanted the long run value to be $10,000? Then what do you think I'm going to put in for x? $10,000. And I'll go 10,000. And then I can solve for n. See what I mean? Now I just have to multiply both sides by 0.00416. Multiplying by 1,000 just moves, or that's 10,000. I said 1,000. So did I say 10 or 1,000? 10,000. Okay, thanks. Then multiplying by 10,000 moves the decimal over 4 spots. $41.60. 1, 2, 3, 4. I think I'm doing that right. Does it come out to 41.6? All right. So then I want my adding amount to add each month to be $41.60. So what was that like? Well, basically you didn't know the amount, so you put an n. Doesn't that make sense algebraically? That's what we always do, right? If you don't know something, you put an n or an x or whatever. Just don't use x because we already have an x in the problem. Then you just solve the problem all the way down to the end, and then this is the key moment where you've solved it and you got this weird x equals n over whatever, and you don't know n, but you know x. You know the final long run value. They tell you that. All right, so let's look at one just like that. Here it is. I'm starting with 2,000 in my checking account. Say I'm spending 10% of my bank balance annually, but compounded each month. What do I need to add each month to be able to maintain a balance of $3,000 in my checking account in the long run? Okay, so you're going to solve this. This is all algebra. You're going to use your calculator only for like doing a little bit of number crunching, but remember the starting with 2,000? It doesn't matter. It's just this part. Don't forget, it's monthly. Compounded each month. What do I need to add each month? Plus n. To maintain a balance of 3,000. Remember not to put in that 3,000 until later, unless, remember that x is going to be 3,000. If you want to, you can put in the 3,000 right away. If x is going to be 3,000, I think that's actually easier. If you put in the 3,000 right away, because that's what these are supposed to be both the same, right? And they want them to be 3,000, then you can just put in 3,000 right away, and I think it's going to come out a lot faster that way. So it's 3,000 equals 3,000 times 1 minus 0.10 divided by 12 plus n. If this part was on a calculator, it'd be really easy, and I'd times that by 3,000. Let me go off to the side, grab my calculator, and do that quick. I get 3,000 equals 2,975 plus n. So I'm going to subtract 2,975 from 3,000. You get 25 bucks. All right. Cool. So that's the last of the things that would be important to know about loans and investments. Do you want another practice problem like that, or are we good? Seeing some nodding, yes. So let's just do one more. They're pretty simple to set up. Let's say I'm going to lose 8%. It's monthly. If I want my checking balance to maintain at $5,000 balance in the long run, do you get how I don't even care how much I start with? It's irrelevant. Solve for how much do you have to put in each month to have a $5,000 balance going in the long run. Again, it's going to take a long time to get there, but that's the point of a long run. So you should be setting up one of these. And then you just substitute in, not X this time, because we know what X is. We know what our long run balance is supposed to be. I'm going to pause for a second, and this is really a crucial moment. Please check with that person I assigned you in a moment. And if one of you is confident you know what you're doing, please explain it to the other. If both of you get the same answer, you're probably doing it right. I'll pause for a second. You're working out. All right, so here you'd have a 5,000. Here you'd have a 5,000. Here you'd have a 1 minus 0.08 divided by 12. And then here, I don't know what the payment is, so I put a plus n. Then I just have to number crunch a little bit. I'm going to pause while I do that. Finishing up the last little part here. So I did, this one comes out to 496. So it's 5,000 equals 4966.67 plus n. Then I subtract that from both sides, so I have 5,000 minus the previous answer, and I get $33.33. So there's your grand total that you should put in every month in order to maintain a $5,000 balance given that situation. And that's all I got for you.